Let's see if you understood what we learned about in the last Vodcast by looking at an example. A suspended object A is attracted to a neutral wall. It is also attracted to a positively charged object B. Which of the following is true about object A? It is uncharged, it has a negative charge, it has a positive charge, it may be either charged or uncharged. Well, to be attracted to a neutral wall, we know that it must have charge. So D and A are out. And now we need to think about whether or not it has a positive or a negative charge. Since it's attracted to a positively charged object B, we're going to conclude that it has a negative charge. Incidentally, the suspended object attracted to the neutral wall would cause polarization inside the wall. Section 17.2, electric force. The electric force, the equation for electric force, is extremely similar to the formula for gravitational force, where the electric force, Fe, is equal to K, a constant, which is given here, 8.9875 times 10 to the 9th. I often simplify it to 9 times 10 to the 9th, Newton meters squared per Coulomb squared. Q1 and Q2 are our charges, and R is the distance between the charges. So again, F is force in newtons, Q is charge, and that's in coulombs, and R is distance in meters. And similar to gravitational force, what this does for us is it gives us the force between 2 point charges, 2 point charges, Q1 and Q2. If you see something like this, FAB means the force exerted by A on B. So in this case, if I wanted to draw a force between Q1 and Q2, this would be the force of object 1 on object 2. Let's look at example 1. Object A has a charge of 2 microcoulombs, and object B has a charge of 6 microcoulombs. Which statement is true? What we're doing here is we're comparing the forces. We're comparing the force of B on A to the force of A on B. And although the charges are different, the force between those two objects will be the same. It will be equal and opposite. Newton's third law tells us that. So the correct answer here is B. Let's move on to vector addition. The superposition principle applies to the electric force, so don't forget to sum the forces in the x and y directions and to take the resultant vector. Let's do an example from mechanics. A boy paddles a rubber raft across a river to the east bank while the current flows down the river from north to south at 1 mile per hour. He's able to paddle at 1.5 miles per hour. Find the magnitude and direction of his velocity. Okay, so the current is traveling from north to south. Remember, we've got north, south, east, west, and the length of that vector is 1 mile per hour. He is traveling toward the east at 1.5 miles per hour. And we need to find his resultant velocity. I've added my vectors head to tail, and the resultant goes from the tail of the first vector to the head of the last vector. There's my resultant. And I need to find two things in order to define my resultant. I need to find the length of the vector, and I also need to find the angle as measured from 0 degrees. So I'll use the Pythagorean theorem to find r. r will equal the square root of 3.25. And then to find my angle, what I'm going to do in this case is I'll find this angle x. I'll use the inverse tangent of 1.5 over 1, and then I'll add that value to 270 to get my final answer. I need a calculator in order to do this. I want to make sure that my calculator is in degrees, so I check the mode. So inverse tangent of 1.5 over 1 is 56.3 degrees. That's this angle. So my entire angle, theta, is 270 plus 56.3, which is 326.3 degrees. So I've got the length of my vector, and I've also got the angle.